Okay, so good morning to all. Okay, so in that last lecture we have covered uh, a whole basis system and the shaft basis system, and also we have discussed regarding to the how to select the fits. Okay, simple technique I have explained in that last lecture. Okay, may I right? Yes. So just I will revise the pointer. Okay, whole basis system. Okay, then what is meant by the whole basis system? Yes, what is meant by the whole basis system? Yes. What is meant by the whole basis system? Yes, anybody? Okay, we are knowing that in that whole.
Constant.
Okay, the size of hole. Okay, the size of hole is kept as the constant here, and the size of shaft is varied. Okay, the shaft size is varied. Okay, and which deviation is zero here in whole basis system? In whole basis system,
Lower.
the lower deviation should be zero. Okay, the lower deviation should be zero. And what is meant by the shaft basis system? Shaft basis system. Shaft, in that shaft basis system, we are knowing that the shaft is kept as the constant. Okay, the shaft size is kept as the constant, and the size of hole is varied, and which deviation is kept as the zero?
Upper.
Okay, the upper deviation is equal to zero. Okay, such systems are called as the whole basis system and the shaft basis system, and generally out of that both, okay, which is prepared?
Whole basis.
Okay, whole basis system is prepared because to produce the fairest size of the shaft with the help of the turning, with the help of the grinding process, it is easy as compared to produce the as compared to vary the size of hole. Okay, so that generally we are using the whole basis system. Okay, so then our today's point is geometrical dimension and tolerance. Geometrical tolerances. Okay, the last point is geometrical tolerance. Okay, geometrical tolerance. Okay, what is meant by the geometrical tolerances? Already we have discussed dimension tolerances. Okay, that limit. Okay, then upper limit, lower limit, difference between that both the limit we are knowing that tolerances. Again, we are having unilateral tolerances, bilateral tolerances, but this term deals with the geometrical tolerances. Then what is meant by the geometrical tolerances? Okay, just a simple definition is there. Geometrical tolerance is nothing but it is, okay, it is a system. Okay, it is a system, and that system is used for defining and communicating. Okay, it is the system, and that system is used for defining and communicating the engineering tolerances. Okay, the engineering tolerances, the engineering tolerances and the relationship. It is a simple technical definition of the geometrical tolerances. In our language, we can call the geometrical tolerance is nothing but it is the language of drawing. Okay, simple. It is the symbolical representation we can call. It is the symbolical representation of the tolerances. It is the symbolical representation of the tolerances. In that geometrical tolerances, we are going to discuss the tolerances regarding to the following points. Which points? Then tolerance regarding to the straightness. Okay, the tolerance regarding to the straightness. Then flatness. Okay, straightness, flatness. Then circularity. Okay, so what is meant by the circularity? How much tolerance is provided? Then cylindricity. Okay, then perpendicularity. Okay, then again parallelism. Okay, parallelism, then angularity. Okay, such type of the tolerances we are going to discuss in that geometrical tolerances with the help of the symbolical representation. Okay, now simply how to remember geometrical tolerance is nothing but it is the symbolical representation of the engineering tolerances. Okay, so again that geometrical tolerances are classified into the following types. Okay, the geometrical tolerances are classified into the following types. What are the types of the geometrical tolerances? Just to see. Okay, just to see the types of the geometrical tolerances. The types of geometrical tolerances. Okay, the first type is form. Okay, form. Then second is location. Okay, location. Then third is the orientation. Okay, orientation related features. Then run out. Okay, run out. And the last is profile. Okay, profile. These are the types of the geometrical tolerances. These are the types of the geometrical tolerances. The geometrical tolerances are classified into the following 5 types. First is the form. Okay, then location, orientation, runout, and profile. Again here, again that form type it will be classified like this. Again, in that form type, it having the 4 characteristics are there. Okay, again it having the 4 characteristics are there. Again for that location, again it having the 3 characteristics are there. Okay, again for that orientation, okay, again for that orientation 3 characteristics are there. Again for that runout there is a 2 characteristics are there, and the profile again there is the 2 characteristics are there. Then how many characteristics are there? Yes, please make summation of that all. How many? Yes.
14.
Okay, so 14 characteristics are there. Okay, 14 characteristics are there related to that geometrical tolerances. Then what are that 14 characteristics? Okay, that we will discuss here. Okay, okay, so one by one just I will explain here. Okay, now see here in that form. Okay, in that form it having 4. What are that? Straightness. Okay, straightness. Okay, then flatness. Okay, flatness. Okay, just I will try it in another way. First I will write down here the form type, geometrical tolerance. Okay, forma. Okay, inside that forma again it having how many characteristics are there? Inside that forma how many characteristics are there?
4.
4. Okay, what are that 4 characteristics? Okay, I will write down one by one. Okay, one by one. First is the straightness. First is the straightness. Then second is the flatness. Okay, then third is the circularity. Circularity. Circularity, and fourth is the cylindricity. Okay, cylindricity. These are the characteristics of that form. Okay, then next, next, yes, next type is yes,
Location.
Location.
location. Okay, next is the location. In that location, we are knowing that how many characteristics are there for the location? 3 characteristics. What are that 3? I will write down here. Okay, first is the position. Okay, first is the position, then second is the concentricity. concentricity, concentricity, and the third is the symmetricity. Symmetry. Then third is the run out. Okay, in that run out, how many characteristics are there? Two.
Two.
First is the circular run out. Okay, circular run out, and second is the total run out. Total run out. Okay, total run out. Then fourth number is the profile. Okay, again inside that profile, how many? Yes,
Two.
two. Okay, in that profile, twos are there. But what are that two characteristics? First is the profile of line. First is the profile of line. Okay, first is the profile of line, and the second is the profile of surface. Profile of surface. Okay, then last which is remaining?
Orientation.
Last is the orientation. Again, in that orientation, how many characteristics are there?
3.
Orientation. In that orientation, these are there. What are? First is the perpendicularity. First is the perpendicularity. Then second is the parallelism. Second is the parallelism, and third is the angularity. Okay, these are the 14 characteristics of the geometrical tolerances. हे तुमच्या 14 characteristics आहेत. Okay, now see here. So we will discuss here one by one what is meant by the straightness, what is meant by the flatness, then what is meant by the circularity, what is meant by the cylindricity, and then we will discuss what is the symbol for the straightness, what is the symbol for the flatness, and then what is the symbol for that all 14 characteristics, and with the help of that symbol, how to read the given drawing. That is our motto. So understood? Understood? Yes. So one by one. Okay. So one by one, we will discuss here what is meant by the straightness. Yes. Anybody? Any idea what is meant by the straightness? When we can call it straight? Yes. Simple. Simple meaning मला सांगा straightness म्हणजे काय म्हणू शकतो आपण? What is meant by the straightness? First आपण we will discuss here the meaning of that characteristics. Okay. Straightness. Straightness. Then what is meant by the straightness? Yes. What is meant by the straightness? For example, suppose this is the pen. Okay, just see. It is visible to all. See, this is the pen. How much that pen is straight? Whether it is straight or whether it is a bent. It is straight or bent? Yes.
Straight.
Means straight means suppose, for example, suppose we are having one component here like this. Okay. This is the component. How much that component is straight? Just tell me. It is straight. It is straight. This component is straight.
No.
No, it is not straight now. Okay. Suppose just suppose this is the line. This line is straight. It is straight.
Yes.
Okay. And suppose once again I will draw here another line. This line is straight. This line is straight. It is straight but not exact straight. No, it is not exact straight. It is exact straight. Exact straight. Okay, so straightness means how much that component is straight. How much that component it will the straight. म्हणजे एखादा component किती straight मध्ये आहे, सरळ रेषेमध्ये आहे. It is called the straightness. Okay, and but in our symbolical representation, okay, symbolical representation. What is the symbol for the straightness in that drawing? How to represent that straightness in the drawing? आपण ड्रॉइंग मध्ये असं लिहू शकत नाही straightness. Okay, they have given one symbol here to represent the straightness. They have given the one symbol. What is the symbol for the straightness? just we have to draw the one line, straight line. Just we have to draw the one straight line. See, this is the symbol for the straightness. Okay, what is the symbol for the straightness? The straightness is nothing but it is showing the how much that component is the straight, and how to represent it with the help of the drawing. Yes, just we have to draw the one straight line. See, this is the symbol for the straightness. Understood? Yes, it is called as the straightness. Then second is the flatness. Okay, flatness. What is meant by the flatness? When we can call that component is flat? Yes. Yes. Suppose, for example, we are having this mobile. Okay, so this is the mobile. Then tell me, this surface is flat or not? Whether that whole surface is flat or it is not flat?
Flat.
It is flat. Okay, जर मी चारी बाजूने check केलं, we can call it is flat. Flatness means it will show the information regarding to the how much that component is flat. For example, okay, for example, suppose we are having one component like this. Okay, this is the component. Okay, this is the component, and I have checked the surface of that component in all the direction with the help of the dial gauge. Dial gauge नावाचे instrument असतं. With the help of that dial gauge, I have checked the surface of that component, and it is showing that less fluctuation. मी काय केलं, dial gauge घेतला. For example, see, this is the dial gauge. This is the one dial is there, and with this dial gauge means it is the measuring instrument. Okay, that dial gauge I have moved on the surface of that component, and here it will showing less fluctuation. आता ह्याला आपण काय केलेलं असतं, ह्या फ्लॅटनेस स्ट्रेटनेसला अगेन वी आर प्रोव्हाइडिंग द टॉलरन्सेस मीन्स फॉर एक्झाम्पल 0.01 मायक्रॉन. ओके, 1 मायक्रॉन, 2 मायक्रॉन लाईक दिस. म्हणजे काय, जर इथं फ्लक्च्युएशन 1 मायक्रॉनच्या आतमध्ये असेल, म्हणजे मला सांगा, इट इज पॉसिबल टू प्रोड्यूस एक्झॅक्ट फ्लॅट सरफेस, एक्झॅक्ट 100% फ्लॅटनेस प्रोड्यूस करणं शक्य आहे का? येस. येस. Yes, please. It is possible to produce 100% correct flatness surface. Yes.
No, sir. No.
It is not possible. Not to again tell me, it is possible 100%. It is possible to produce exact 100% straight component. It is not possible. Okay, so that here also we are providing the tolerance in the term of the flatness or straightness. म्हणजे आपण ह्या ठिकाणी काय करणार आहे, like this. Okay, ह्या componentला मी tolerance कसं देणार आहे? For example, like this, I will provide the tolerances. Okay, just 1 minute. Suppose this is the component, and okay, suppose I have show like this. Okay, see, it is called as the control feature. Suppose I have draw here one straight line and write down here 0.21. What is the meaning of this? Yes, what is the meaning of this control feature? What is the meaning of this? Yes. Yes, please tell me, what is the meaning of this? The meaning काय असेल? Suppose this is the one component आहे, shaft आहे. This is the shaft. आणि shaftच्या वरती या ड्रॉइंगच्या वरती मी असं पिक्चर तुम्हाला दिले. Then tell me, what is the meaning of this? This symbol is indicate. कशाचा symbol आहे? This straight line is indicate
Straightness. Yes.
straightness. This line is indicate this symbol is indicate the straightness. Okay, straightness. The straightness of that component, okay, the straightness of that component should be within 0.01. म्हणजे जर समजा ह्या componentची straightness 0.01 मायक्रॉनच्या आत ह्याच्यामध्येच असेल, एवढं व्हेरिएशन जर असेल तर इट इज करेक्ट, आपण म्हणू शकतो इट इज करेक्ट, इट इज ऍक्सेप्टेबल. जर मला सांगा हा component आहे, okay, suppose this is the component and I have shown here like this. The straightness of that component 1 micron or 1 mm काय असेल ते 1, समजा सपोज 1 असेल, 1 micron असेल, आणि मी डायल गेजने हे component चेक केला. I have checked the surface of that component, okay, for the straightness, and the variation it will showing 2 micron. It is acceptable. Straight आहे म्हणू शकतो आपण component, acceptable आहे का?
No.
No.
का? Why no? Because it is not in tolerance zone. येते का लक्षात? सुरुवातीला तुम्हाला काय दाखवलं जातं, त्याचा सिम्बॉल दिला जातो. सिम्बॉल काय इंडिकेट करतो, तुमच्या कॅरेक्टरिस्टिक इंडिकेट करतो, स्ट्रेटनेस, फ्लॅटनेस, सर्क्युलरिटी काय असेल ते. आणि नंतरचं जे काय असतं त्याला टॉलरन्स म्हणतात. इट इज कॉल्ड एज द टॉलरन्सेस. नेक्स्ट व्हॅल्यू, ओके, इट इज कॉल्ड एज द टॉलरन्सेस. Okay, that point you have to remember. That point also we will discuss here. Okay, so understood, flatness means how much that component is straight, and the symbol for the straightness is the just straight line is there, and for the flatness, flatness means how much that how much the surface of that component is the flat. Okay, just example. Okay, just example, suppose this is the component. Okay, and I have check the surface of that component with the help of the dial gauge. Okay, dial gauge, and the variation it will be in that tolerance zone, that we can call it is the flat. And how to show the flatness? With the help of the drawing, with the help of the symbolical representation. Just see, this is the symbol for the flatness. This is a simple symbol. So this is the symbol for the flatness. Yes, understood? So this is the symbol for the flatness. Then tell me how to read this drawing. Suppose this is the one shaft or any component is there, and on that component, suppose they have given the control feature. As a box दिला जातं त्याला काय म्हणतात, control feature. Okay, suppose they have given like this. Then please read this figure and tell me. Yes, please read this figure. Yes, Asmita.
Flatness is 0.02.
What is this 0.02? What is this 0.02?
Tolerance.
It is the tolerance. म्हणजे जर ह्या कॉम्पोनंटचा फ्लॅटनेस 0.02 ह्याच्यामध्ये जर व्हॅरी होत असेल तर हा कॉम्पोनंट आपण फ्लॅट आहे म्हणू शकतो का? म्हणू शकतो का नाही?
Yes,
sir.
म्हणू शकतो. Just tell me next example. Suppose this is the component, and here I have shown the control picture like this. And tell me what is the meaning of this?
Flatness is 0.01.
म्हणजे तो वाचताना कसं वाचायचं? हाऊ टू रीड इट? the permissible straightness should be 0.01 micron like this. म्हणजे जर ह्या कॉम्पोनंटची स्ट्रेटनेस जर ह्या 0.01 मध्ये व्हॅरिएशन होत असेल, अशी जर आली तुमची लाईन, ओके, जर लाईन तुमची अशी आली आणि ह्याचा टॉलरन्स किती दिला आपल्याला? 0.01 दिलाय. जर तुमची लाईन एवढ्या फ्लक्च्युएशन मध्ये आली तरी पण आपण काय म्हणायचं आहे? वी कॅन कॉल इट इज द स्ट्रेट. जर मला सांगा 0.03 आली तर दिस कॉम्पोनंट इज द नॉट स्ट्रेट. So understood?
Yes, sir.
Okay. So this is about the straightness and flatness. Then next, okay. So next, what is the next? Yes. Next characteristics.
Circularity.
Okay, circularity. Okay, then first up we will discuss what is meant by the circularity. When we can call it is the circular. Yes, what is meant by the circularity? For example, suppose we are having one circle. Suppose this is the circle. Okay, when we can call this circle is correct. Then we can call this circle having the good circularity. Yes. Then how we have to measure it, or when we have to judge it whether that circle is good circularity or not? Yes.
When the component is exact circular.
Yes. How to check it? Just here, suppose this is the center point. Okay, this is the center point, and I have checked the radius in all the directions. Suppose I have checked this radius, again I have checked this radius, again I have checked this radius, also I have checked this radius. If the radius in all the direction are same, जर ह्याची ह्या सेंटर पॉइंट पासून या सर्कलची रेडियस ह्या डायरेक्शनला समजा आहे, समजा suppose this is 10, this is 10, or this is 10, then we can call it is having the good circularity. It is the circularity. Am I right? If suppose this circle we have produced here like this, okay, like this, and I have checked their radius. Okay, suppose I have checked the radius of that circle. Okay, and it will showing in this direction, it will showing 10, sometimes it is 9, 8, 9.5, or 10. Again, it is circularity. It is not an exact circularity. It is not an exact circularity, but to produce that exact circular, okay, component, to produce the exact circular component, it is not possible. आपल्याला एक्झॅक्ट 100% सर्क्युलर कंपोनंट बनवणं शक्य नाही, म्हणून आपण त्याला काय देतो, टॉलरन्स देतो. ओके, सो दॅट वी आर प्रोव्हाइडिंग द टॉलरन्सेस. जर समजा हे तुमचं व्हॅरिएशन काय मायक्रॉन मध्ये असेल, 0.1 मध्ये असेल, 1 मायक्रॉन मध्ये असेल, 2 मायक्रॉन मध्ये असेल, ओके, जर असं एवढं जर अलायबल मध्ये असलं तर वी कॅन कॉल इट द सर्क्युलरिटी. Okay, so it is called as the circularity. This is the concept of the circularity. But how to show that circularity in the form of the drawing? What is the symbol for the circularity? Okay, to show the circularity, just we have to draw a small circle. Just this is the symbol for the circularity. This is the symbol for the circularity. Okay, suppose example, suppose so this is the one rod is there. How to read it? What is the meaning of this? Yes. Yes, please read it. What is the meaning of this?
Permissible circularity is 0.01.
Means what? Exact tell me the meaning of this. मला ह्याचा meaning सांगा पूर्णपणे काय असेल नेमकं. Yes.
त्या कंपोनंटची सर्क्युलरिटी 0.01 मध्ये व्हॅरी झाली तर एक्सेप्टेबल असते.
Okay, good. This component is the acceptable. Okay. म्हणजे जर हे सर्कल एक्झॅक्ट जर 100% जर सर्क्युलर नाही आलं तरी चालेल. किती व्हॅरिएशन पाहिजे त्याच्यामध्ये आपल्याला? How much variation is allowable here? That 0.01 micron variation is allowable. It is called as the circularity. So understood? Yes.
Yes, sir.
Remaining students.
Yes, sir.
Okay. So next, what is the next? Yes.
Cylindricity.
Cylindricity. Okay. Cylindricity. Okay. Then we have seen here straightness, flatness, circularity, and cylindricity. Sorry, circularity. Then what is meant by the cylindricity? When we can call it is the cylindrical surface. Yes. What is the actual meaning of that cylindricity? Yes. See, this is the circularity. Yeah? Okay. So this is the circularity means in the all the direction the radius should be same. Okay. Then we can call it the circularity. And when we can call it the cylindricity. For example, suppose we are having one cylinder. For example, see, this is the one cylinder in there. See, this is the cylinder. Okay. Now we have to understood the concept of the cylindricity. See, this is the one cylinder in there. Okay, now we have to check its cylindricity. The cylindricity means what? Okay, just see. Suppose we have checked this circle. Okay, at this point we have checked this circle. Okay, this circle we have checked. Okay, again we have to check this circle at this point also. Again we have to check this circle at this point. Okay, again we have to check this circle. Okay, like this throughout we have to check. Okay, throughout we have to check this cylinder. And if the variation of that circles, all the circles are in within the limit, then we can call it is the cylindricity. हा सिलेंडर एक सिलेंडर आहे आणि या सिलेंडरची मी थ्रोआउट सर्कल चेक केली पूर्णपणे. ओके, थ्रोआउट सर्कल चेक केली आणि सर्कल म्हणजे जर तुमच्या टॉलरन्स झोन मधला आला व्हॅरिएशन असेल, वी कॅन कॉल इट इज एक्सेप्टेबल. It is the cylindricity. So understood the meaning of the cylindricity and circularity? Yes.
Yes, sir.
Means you can remember this. Circularity means it is for the 2D and it is for the 3D. It is right. It is right. Okay, so it is called as the circularity. So it is the circular, sorry, it is the cylindricity. It is the circularity. And how to show that cylindricity in the form of the drawing? What is the symbol for the cylindricity? Yes. What is the symbol? Just here. The symbol for the cylindricity is just we have to draw one circle and both the side we have to draw the lines. This is the cylindricity. This is the symbol for the cylindricity. Okay, example. For example, suppose tell me. Please read it. What is the meaning of this drawing? Yes.
Permissible cylindricity varies within 0.02.
जर मी याची सिलेंडरसिटी चेक केली आता, ओके, म्हणजे ऑल सर्कल मी थ्रोट चेक केली आणि त्या सर्कल मध्ये जर मला 0.02 मायक्रॉन एवढं जर व्हेरिएशन आलं तर मग काय म्हणू शकतो मी इथं? वी कॅन से इट हॅविंग सिलेंडरसिटी, नो प्रॉब्लेम, इट इज ऍक्सेप्टेड. सो अंडरस्टूड? Yes.
Yes, sir.
Yes.
Yes. Okay. Okay, and these are the simple symbols. Okay, that symbol, it is important. Just you have to remember the symbols. Okay, and the one more important point is related to that form feature is, okay, for that all the features. Okay, that one more point is there here. Datum is not required. That point you have to remember. Datum is not required. Okay, then what is meant by the datum? That I will explain here. Datum is not required. Not required. What is meant by the datum? Datum is nothing but it is the reference point. It is the reference, any point, any line, any surface, okay, any profile. म्हणजे एखादा मी एखादा पॉइंट घेतला, रेफरन्स पॉइंट. Okay, then that reference point is called as the datum. But for that feature, that straightness, flatness, circularity, cylindricity, it is not required to take the reference point, reference line, reference surfaces. Means it is not required the datum. Okay, for that core feature, we have not required the datum. Okay, so understood? Yes. Okay, now see here. Here I will explain that datum, how that datum is represented. Okay, that datum, suppose this is the component. Suppose this is the component and the datum is showing with the help of that inverted triangle. A second inverted triangle draw केलेला असतो भरीव. Okay, see, this is the inverted triangle. And here we have to write down one letter, E. E means, see, it is called as the datum. Datum means reference point. Okay, reference point. म्हणजे ह्या पॉइंटला, ह्या सरफेसला धरून रेफरन्स आहे. What is the reference? Reference E. म्हणजे ह्या सरफेसला surface reference here, like this. Okay, that point also we'll discuss. But before that, just have to remember, datum is nothing but it is the reference point, line, or surfaces. But for this feature, it is not required. Okay, so understood? Symbol for the straightness, flatness, circularity, and cylindricity. Okay, so any doubt? Yes. Can I take next?
Yes,
Yes.
sir.
Yes, sir.
Okay. The next is the, what is the next?
Location.
Location.
Position.
Okay, we'll take location. First of all, we'll take the location. Okay, location. Okay, location means what? It is showing the place. Okay, just again that location, it having how many characteristics are there? 3 characteristics are there. Right? Okay, then first is the
Position.
first is the position. Position. Then second is the yes concentricity, and third is the symmetricity. Okay, these are the three characteristics is there in that location. Okay, then first up on we will discuss here what is meant by the positioning, what is meant by the concentricity, and what is meant by the symmetricity, and then we will try to draw their symbol. Okay, then tell me what is meant by the position. Yes, what is meant by the position? Okay. I will explain here. Position. Okay, the meaning of the position is suppose we are having one plate in there like this. Just okay. Okay, suppose this is the one plate is there, and okay, see this is the at the center of that plate we have make one drill. For example, for this distance is the 20, and again this distance it will be the 20. Okay, okay, so this is the center point for this circle. Center. Okay. Positioning means what? From this point. Okay, from this pointer, your hole it will be at the 20 mm above side. Okay, and from this pointer, your hole is at the 20 mm this pointer. So this is the position for this one. So understood? Position of that hole is the 20-20. Okay, in vertical direction 20 means it is the y, it is the x. Yeah, right. In that x 20, in that y 20. Okay, so this is the position for that one. It is the position. It is called as the position. Okay. जर आपल्याला असं ड्रॉइंग मध्ये दिलं, suppose in that drawing they have given like this. Okay, but unfortunately again it is not possible to produce exact hole at this 20 and at this 20. Okay, and suppose your hole is drilled at this point, at this point like this, at this pointer, and suppose this variation is within tolerance. जर हे variation तुमच्या tolerance मध्ये असेल, if this variation is in tolerances, then again it is acceptable or rejectable. This position,
Accepted.
it is acceptable. Okay, so it is called as the position. And what is the symbol for the position? Just to say the symbol for the position is like this. Just we have to draw the circle and we have to draw the center points like this. So this is the position. Okay, suppose here, okay, suppose here they have written like this. Then tell me meaning of this. The position of that hole, okay, the position of that hole should be within 0.02 tolerance. म्हणजे हे जे होल जे आहे तुमचं हे सपोज दिस इज द होल. ओके, जर हे होल आपल्याला एक्झॅक्ट किती साईजला पाहिजे, 20-20 ला पाहिजे, 20-20 ला पाहिजे, बट अनफॉर्च्युनेटली इट इज मॅन्युफॅक्चर्ड ॲट लाईक दिस 20 and 20.51 like this, and if this variation is in within tolerance, again it is acceptable. It is called as the position. Okay, so understood? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
And see, this is the symbol. So this is the symbol for the position. Okay. Then next is the concentricity. Yes, what is meant by the concentricity? Yes, anybody? Any idea? What is meant by the concentricity? Yes. What is meant by the concentricity? When we can call it is the it having the concentricity. For example, suppose I will draw here Suppose I'm going to draw here one cylinder. So this is the circle. Okay. Again, suppose it is the circle. Now I have to show their concentricity. Concentricity. Okay. Suppose this is the center point of the circle. Again, this is the center point of the this circle. Example. For example, this is the circle 1. We can call this the circle 2. Okay, circle 2. Now we have to check their concentricity. Okay, and concentricity is nothing but okay, the center of the both the circles should be matched. The center of the both the circles should be matched. Okay, if the center of that both the circles are in within the line, then we can call it having the concentricity. जर हे दोन्ही सर्कल सेंटर पॉइंट ओके मॅच होत असतील then we can call it is the concentricity. If it is not matched, then we are not saying it is the concentricity. It having the concentricity. Okay, so understood the meaning of the concentricity. जर हे दोन center point match झाले, okay, that both the center point are matched, then we can call it is the concentricity. But in actual practice during the manufacturing, again it is not possible to match that both the centers. Somewhat variation will become, and if suppose that variation it will be within the tolerances, then we have to show with the help of this concentricity symbol. Okay, for example, and how to show that concentricity? What is the symbol for the concentricity? The symbol for the concentricity is like this. Okay, both the circle we have to do like this. It is called as the concentricity. Okay, so understood? Yes.
Yes, sir.
Yes, sir.
Okay, means for example, suppose this is the both the circle. Okay. Just one. No. No. See, this is the concentricity and this is the symbol for the concentricity. Means the center point of the both the circle should be matched. Okay, the center point of the both the circle should be matched. Then we can call it the concentricity. Again, example. If they have given like this, yes, what is the meaning of this? Means the concentricity of that component should be within tolerance 0.03. जर ह्याची concentricity समजा हे सर्कल जर मॅच नाही झालं आणि ते सर्कल फॉर एक्झाम्पल समजा एवढं व्हॅरिएशन दाखवत असेल आपल्याला like this. Okay, and this variation is within these tolerances. Again, it is acceptable. Okay, again it is acceptable. So for showing such type of the features, we are using that geometrical tolerances. Okay, so understood? Yes.
Yes, sir.
Okay, now see, this is the
Yes, sir.
concentricity. Then what is meant by the symmetricity? Then we can call that component having the good symmetricity. Yes. 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 Anybody? Symmetricity. Symmetricity. For example. Okay. Suppose
When
I'm
the
going-
component is symmetrical.
okay, means okay. Just I will take the example here. Suppose, for example, Just I will draw here one component like this. So that C channel I have drawn. If this distance and this distance are same, equal, then we can call it is the symmetrical component. Okay. Okay, if this distance and this distance are same, then we can call it is the symmetrical component. Okay, it is called as the symmetricity. Okay, if suppose here they have given like this. Okay, first up we will see here the symbol for the symmetricity is like this. So this is the symbol for the symmetricity. Three lines are there. Okay, small, bigger, small. So this is the symmetricity. And if they have given like this, then what is the meaning of this? Yes. Yes. The symmetricity of that component should be the tolerance zone within 0.02. If it is, if this distance is not equal, suppose if this both the distance are not equal and the variation is there, and that variation is in within that tolerance, again we can call it is the symmetry. Okay, and this is the symbol for the symmetricity. So understood? When we can call it is the symmetrical. Yes.
Yes, sir.
And the important point is related to that feature. Here, okay, here for this location, we have to require and datum is required here. Okay, datum is required. It means to show that position, to show that concentricity, to show that symmetricity, we have to require the datum. Means we have to require one reference point, we have to require one reference line, we have to require reference surfaces. Okay, that is the meaning of that. Okay, the datum is required here. Okay, the datum is required. Okay, the datum is the required. Okay. So understood. So these are the symbols. Then next, what is the next? Yes. Third. Yes. Third geometrical type of tolerance is the run out. Okay. Again, it having the two characteristics are there. First is the yes,
Circular runout.
the circular run out, and the second is the yes
Total
total
runout.
run out. Total run out. Whether you are knowing about the run out, when we can call it is run out. What is meant by the run out in Marathi? We can say run out. Yes. Run out. What is meant by the run out? Whether you have heard this word run out. Out like out. एखादा चाकाला out आलाय. Yes. Whether you have seen the feel of the bicycle. Okay. And where remove the out of the feel of that bicycle. Out काढतो आपण. Yes. Out. For example, suppose we are having one wheel. Okay, suppose this is the bicycle wheel. Suppose this is the bicycle wheel there. So this is the bicycle wheel there. This is their center. Bicycle wheel is there. If there is the out to that field, then how that field is looking? Yes. If there is out, means it is not in circular position. Means that time it will showing like this. Okay. Like this, for example, like this. Means it having the out. Means it's showing the fluctuations. Suppose it is rotating. Okay. During the rotation, suppose that field we have rotated at the 3D system. Okay. During the rotation, that field does not show any fluctuation. Up down दाखवणार नाही आपल्याला. दाखवेल का fluctuation? Okay, if it is not run out, okay, if there is a no any out to that field, and suppose that field we have rotate, then tell me it is showing the variation during the rotation. Yes, whether it is showing the variation.
No.
It is not showing the variations because it does not have any out, any run out, any. Okay, and if there is out, okay, if there is any out, then suppose we have to rotate this wheel at 3 degrees 60. During that, it will showing the up and down. It will showing the up and down. Means it is showing the variations. Understood? It is called as the runout. Okay, then what is meant by the circular runout and total runout? Okay. Okay, again it is very simple. Okay, circular runout. For example, suppose we are having one shaft there. Okay, suppose this is the shaft. Suppose this is the shaft there. Or one circular rod in there. Okay. And we have to check this circular runout. Circular runout. For example, suppose at this point, okay, or at this point we have put one dial gauge. Okay. Suppose this is the dial gauge. This is the dial gauge. We have put one dial gauge here, and we have rotate that shaft or rod. Okay, suppose we have rotated this component at 360 degree. 360 degree. If and we have fixed this point. Okay, point मी fix केला आणि काय केला shaft rotate केला. आता काय होईल? If there is out, okay, if there is any out, okay, if there is any fluctuations are there during that, what will happen? This dial gauge it will moving, it will show the fluctuation. ना? एक शाफ्ट आहे, समजा शाफ्ट आहे, शाफ्टला मी रोटेट केला आणि ह्याच्यावर डायल गेज ठेवलं. जर त्या शाफ्टला आउट असेल तर काय होईल? डायल गेज काय करेल? इट विल शो इन द फ्लक्च्युएशन. Yes or no?
Yes, sir.
Then it is called as the circular runout. Means circular runout means we have to check the runout at one fixed point. One fixed point. It is called as the circular runout. And then what is meant by the total runout? Okay, we have checked throughout this surface. Throughout this surface. म्हणजे काय केलं आपण? डायल गेज पूर्णपणे त्याच्यावर आपण मूव्ह केली. ओके, डायल गेज हे काय केला? शाफ्ट, we have rotate that shaft and we have check the whole the surface of this shaft. त्या शाफ्ट पूर्ण शाफ्टच्या सरफेस वरती डायल गेज मूव्ह केली. ओके, and whatever the minimum and maximum variation are showing, okay, whatever the minimum and maximum variation it will be showing that dial gauge. Okay, the maximum and the difference between that maximum and minimum variation it will showing the total. जर मी एकाच पॉइंटला डायल गेज फिक्स केला, शाफ्ट रोटेट केला आणि ह्याच्यामध्ये काय जर व्हॅरिएशन दाखवत असेल, then it is called as the circular runout. आणि जर टोटल सरफेस वरचा जर रनआउट मी चेक केला, पूर्ण सरफेसला जर डायल गेज मी मूव्ह केली आणि शाफ्ट रोटेट केला आणि त्याचं जर फ्लक्च्युएशन मी काढलं अप डाऊन ओके, अप डाऊनचं फ्लक्च्युएशन जर काढलं, it is called as the total runout, and at this point it is called as the circular runout. So understood? Yes, it is a very simple concept. समजताय का? Yes or no?
Yes, sir.
Okay, then how to show it? What is the symbol for that circular runout? Okay, see here, the symbol for the circular runout is just have to show arrow. Okay, the end of that arrow should be solid. So this is the circular runout, and the total runout we have to show like this. This is the symbol for the total runout. So this is the symbol for the total runout. Okay, that two symbol you have to remember: circular and total runout. Okay, so understood? Yes.
Yes, sir.
Yes, sir.
Okay, again, important point is here also we have to require the datums. Okay, the datum is required. Okay, so fourth is the fourth. Yes,
Profile.
Profile. Profile. Then again, how many types are there for the profile?
2 types.
Okay, again it having the two characteristics are there. First is the
Profile of line.
profile of line. Profile of line. It is the profile of line. Profile of line, and second is the profile of surface.
Surface.
Then first of all, we will discuss here what is meant by the profile of line and a profile of the surface. Okay. For example, suppose say the example of the mobile. Okay. Suppose this is the mobile. See this is the mobile. Okay. See this is the profile of the mobile. Okay. So this is called as the profile of the mobile. It is called as the profile of the mobile. Okay. Now see out of that, then tell me what is meant by the profile of the line and profile of the surface. See, this is the profile of the surface. Purna surface profile hai, it is called as the profile of the surface. And suppose I have seen here only this line. It is called as the profile of the line. It is called as the profile of the line. So I'll write down here. See, profile of the surface. Okay, just I will take the example of the mobile. See, this is the profile of surface. So this is the profile of surface of your mobile. Okay. And what is the profile of line? Just I have to show the profile of line only like this. Okay, line. So this is the radius, and this is the straight. It's called as the profile of line. It is the profile of surface. Okay, understood? Yes. For example, take example of the charger. Okay, what is the profile of your charger? For example, Redmi, like this. Again, it is similar. It is the profile of surface, and again it is the profile of line, like this. So understood? The profile of line, profile of the surface means it is the 3D, we can say. It is the line of profile of line for the 2D, like this. Okay, then what is the symbol for that? Okay. The symbol for that profile of line, it will be like this. Okay, it will be just have to draw like this. This is the symbol for profile of line. And this is the symbol for the profile of surfaces. It should be closed. Okay, so this is the symbol. Profile of line, profile of the surface. Okay. Yes. Understood?
Yes, sir.
Okay, and what is the last? What is the last? The last is the orientation. Okay, orientation. Okay, in that orientation, what are features are there? Perpendicularity. Okay, then what is meant by the perpendicularity? Then parallelism. Okay, and third is the angularity. Okay, when we can call it is perpendicular? Yes. Perpendicularity means what?
Orientation of component is perpendicular.
Okay. Parallelism, when two planes are not cut to each other, then it is called as the parallel. And angularity, having some angles. Okay. So I will just write down the symbol here. For the perpendicularity, we have to use this symbol. For the parallelism, we have to use this symbol, and for the angularity, we have to use this symbol. And the important point is, for that orientation, again it requires the data. So directly I will take the example here, data. Okay, for example, suppose Suppose this is the one component. So this is the component. Okay. So datum, how to represent the datum? Inverted triangle like this. Okay. Here you can write down any letter A, B, C, D like this. A, and if they have given like this, how to read it? Yes. How to read it? Yes, please tell me. Yes. The perpendicularity, this symbol is indicate the perpendicularity. This is indicate the tolerance zone, and this is indicate the datum. Then how to read it? This surface, okay, this surface should be perpendicular to this surface. Okay, the perpendicularity should be within tolerance of 0.02 micron with the datum A. See, this is the reference point. It is called as the datum. Okay, so understood? Yes. हा रेफरन्स पॉइंट असेल. हा सरफेस या सरफेसला परपेंडिक्युलर पाहिजे आणि त्यांचं व्हेरिएशन जर एवढं आलं तर आपण अगेन इट इज ऍक्सेप्टेबल. ओके, सो सपोज द नेक्स्ट एक्झाम्पल ऑफ द पॅरलिझम इज लाईक दिस. If they have given like this, what is the symbol for the parallelism? So this is the symbol. Yes, please read this, right? Yes, please read this. Yes, Asmita, what is the meaning of this?
Parallelism should be within tolerance 0.02 with datum A.
Means what? With datum means what? This surface should be parallel with this surface. Okay, this surface should be perpendicular with this A surface like this. This is the meaning of that datum. Okay, understood? Yes.
Yes, sir.
Okay, these are the 14 characteristics of your geometrical tolerances. So next is control, feature control frame. Okay, already I have explained here feature control frame. So once again I will explain here feature control. Feature.
So,
Yes.
profile datum required आहे का नाही?
Yes, yes, I have. It is required. Feature control. Feature control. Feature means how they are showing the drawing. Okay, they will showing the drawing like this. Okay, so it is called as the feature control frame. Okay, in that such type of the compartments are there, boxes are there. Okay, in that first box, suppose they will write down here like this. Okay, like this. Suppose here they will write down here. Okay, here they will write down here A, B. Then what is the meaning of this? Yes, in that first compartment. Okay, the first portion it will indicate the. Yes, what is it? It is indicate the geometrical tolerances, or we can say the geometrical features. Okay, geometrical characteristics. These are the characteristics. No? They are showing the symbol. It is called as the geometrical characteristics. Okay, then second compartment it will indicate the tolerance zone. Right? It is the tolerance zone. Again, it is indicate the, yes, it is the primary datum. It is the primary datum. Then it is the secondary datum. It is the tertiary datum. Okay, these are the datums. These are the datums. See, this is the characteristics, tolerance. Okay, in this manner, we have to show the control feature. अशा पद्धतीने आपल्याला ड्रॉइंग मध्ये देणार ना. Yes or no? Yes or no?
Yes, sir.
Yes.
Okay. Example. For example, suppose they have given like this. Then tell me, what is the meaning of this? It is called as the control picture. Okay, so this is the control picture. In that control picture, here they will write down here like this. Yes, like this. Again, they will give like this also. Okay, again they will give like this also. What is meaning of this? The straightness of that component should be within tolerance of 0.2 mm to micron. Okay, then circularity should be within tolerance zone 0.02. Then this surface should be parallel with respect to datum A, means with this surface within the tolerance zone 0.2 mm, like this. Okay, like this they will show in that drawing. It is called as the control feature frame. Okay, so understood? Yes or no?
Yes, sir. Yes, sir.
So that geometrical tolerances are completed. So right now we will draw that all the symbols here. 14 symbol we will draw here. Okay, then 14 symbol we will draw here. Yes, please tell me. That we'll try to draw that all the symbol here, that 14 characteristic symbol. So this is the types of the tolerance. Okay, and then characteristics. Okay, symbol and datum is required or not. Okay, then please help me. Okay, so I will write down here serial number. Okay, serial number. Then yes, types of the tolerance. Types of the geometrical tolerance. Then characteristics. Then their symbol. Okay, and then datum is required or not. Datum, yes or no. Okay, then what is the first types of the geometrical tolerance symbol? Is the form. Am I right? Yes. Yes.
Yes,
Then
sir.
in that form again it is the first is the straightness. Okay, first is the straightness. Okay, then what is the symbol for the straightness? Just draw
Straight
the
line.
straight line here. Then second is the flatness. Okay, what is the symbol for the flatness? This is the symbol for the flatness. Then third, circularity. What is the symbol? Just draw the circle. Then fourth is the yes. Fourth is the
Cylindricity.
Cylindricity.
okay cylindricity. The symbol for the cylindricity is the like this. Okay, here datum is required. No, datum is
Not
not
at all.
required. Okay, so this is the first type. Then second
Location.
Location.
is the location. Second is the location. In that location, yes, first is the position. The symbol for the position is the just circle and their axis like this. Then yes, yes. Next is the concentricity, na? Okay, so symbol for the concentricity is like this. And third is the symmetry like this. Okay, here datum is required. Yes, yes required. Then next
Run out.
third is the again runout having two types. First is the
circular.
yes, circular runout. Symbol for the circular runout is just a arrow. That arrow should be like this. And the next is the yes. Next
Total runout.
Total.
total runout, and the symbol for the total runout is two arrow like this. Okay, here datum is required. Yes. Then next
Profile.
okay, profile. What is the profile? Then again it having two characteristics. Yes, line of profile and surface of profile. For the line, what is the symbol? Just we have to draw this open, and for the surface we have to close it. Okay. Again, it is datum is required. It is optional. Sometime it is required. Sometime it is not required. Optional, we can say. Okay. And then last is the yes
Orientation.
orientation. Again, that orientation having the three characteristics are there. Orientation. Orientation. First is the perpendicularity. Then second is the parallelism, and third is the angularity. For the perpendicularity, symbol this like this. In parallelism and the angularity. Again here datum is required. Yes. Okay. Now this are 14 characteristics along with their symbols. Okay, so understood? Yes.
Yes, sir.
Yes, sir.
Okay. In the examination, how they will ask the question? Okay, can I clear it? Okay, in the examination, they will ask the question like this: pair the match. Okay, match the pairs. So match the pairs. Match the pairs like this. Suppose here they will on one side A and B. Okay, here they will write down here like this position. Okay, then second perpendicularity. Okay, and here we will do the cylindricity. In this side, they will write down the symbols like this. Here, we see like this. They will ask the question. Then tell me, yes. For the position, what is the symbol?
B.
B is correct. Then for the perpendicularity,
A.
A.
A. Okay, and for the cylindricity, C.
C.
Okay, like this they will ask the question. Okay, so understood?
Yes, sir.
So sometime they will ask the question like this also. Okay. Draw the figure or write down the meaning of this figure. Okay, in this manner also they will ask the question. Okay, in that how to write down? Yes. What is the answer for that? The circularity of that component. The circularity of this component within tolerance 0.02 micron, like this. Okay, so understood? Yes.
Yes, sir.
Okay, so this is about the geometrical tolerances. Okay, so any doubt, any problem regarding to that? Yes. Okay,
No, sir.
so once again I will take review. Okay, now this chapter is completed. Okay, now see here in that chapter which point we have covered here, limit. First is the limit. You know what is meant by the limit? Yes, what is meant by the limit? Then we have covered here the tolerances. Okay, tolerances. Then yes, sizes, basic size, normal size, like this. Then deviation. Okay, deviation. Then yes, zero line. Okay, then yes, yes,
Allowance.
okay, allowance. Then heat. Then yes, full basis, full and shaft base system, and G, geometrical tolerances. Okay, that much point we have covered in this chapter. Okay, then what is meant by the limit? Limit is nothing but what? Yes, limit is nothing but it is the
2x.
permissible sizes. Okay, permissible sizes we can say, or allowable sizes. Okay, again it having upper limit. Okay, upper limit and the lower limit. Okay, then what is meant by the upper limit? Yes, upper limit is nothing but it is the maximum allowable size. Maximum allowable size. And what is meant by the lower limit? It is the minimum allowable size. Minimum allowable size. Am I right? It is the minimum allowable size. It is correct or wrong? It is correct.
Yes, sir.
Then what is meant by the tolerances? Tolerance is nothing but yes, the tolerance is nothing but it is the algebraic difference between upper limit minus lower limit. Am I right? Okay, and actual meaning of that tolerance is nothing but it is the permissible variation in the dimension. Permissible variation. It is the permissible variation. That much variation we can allow. Okay, then what is the types of the tolerances? Yes, what are the types of the tolerances?
Unilateral and bilateral.
Okay, the unilateral tolerances and the bilateral tolerances. Then tell me what is meant by the unilateral and bilateral? What is meant by the unilateral? Yes. What is meant by the unilateral? Yes.
We can show tolerance
Okay,
only one side of basic size.
okay, when we are showing the tolerance on only one side of the basic side, Means either we have to show on the plus plus side or either we have to show on the negative side. Then we can call it the unilateral tolerances. And when we are showing the tolerance zone, okay, on the both the side of the basic size, means we have to show on the plus minus like this, and it is called as the bilateral tolerances. Okay, so understood? Okay, then what is meant by the basic size? Yes, what is meant by the basic size?
Size after giving tolerance.
Okay, the size after giving the tolerances, it is called as the basic size. Okay, then what is meant by the actual size? What is meant by the actual size?
After production.
The size of part after the production. Okay, after the production, whatever actual size it is showing, it is called as the actual size. Then what is meant by the deviation? What is meant by the deviation? Yes,
Actual size minus basic size.
actual size minus basic size, it is called as the deviation. Okay, then what is meant by the fundamental deviation?
Deviation closer to basic size.
Okay, the deviation which is closer to the basic size, it is called as the fundamental deviation. Okay, then what is meant by the upper deviation? Yes, what is
Upper limit minus basic size.
upper limit minus basic size. And what is the lower deviation?
Lower limit minus basic size.
Lower limit minus basic size. Okay, then the next is the what is meant by the allowance. Yes, yes, what is meant by the allowance?
Difference between two meeting.
Okay, it is the difference between two meeting parts. Then when we can call it is the positive allowance, and when we can call it is the negative allowance. Yes, positive allowance or negative allowance. Positive and negative. And tell me when we can call it is positive and when we can call it is negative.
When shaft size is small and hole size is greater, then it is positive allowance.
Okay, if shaft is small and hole is the bigger, then it is called as the positive allowance, and vice versa, it is called as negative allowance. Then tell me in which pit it is positive and in which pit it is negative. In which pit it is the positive allowance is there?
Clearance.
In the clearance pit there is the positive allowance, and in the in interference pit it is the
Negative.
negative allowance. Okay, then tell me what is meant by the pit. What is meant by the pit? Yes, what is meant by the pit? Yes, what is meant by the pit? The remaining students, what is meant by the pit? Pit is nothing but it is showing the relationship between, or it is showing, or it is indicate the tightness and looseness between two meeting parts. Okay, then again, what are the types of the pit? It having the three types: clearance pit, then interference pit, and the transition pit. Then tell me what is meant by the clearance pit, when we can call it is clearance pit, when we can call it is the interference pit and transition. Tell me fast. Yes,
Tolerance zone of is above and shaft zone is below.
means
Then it is clearance pit.
okay, means simple. Please tell me in simple language whether shaft is small or hole is small here in that clearance pit.
Shaft is
Shaft
hole
is
is
small, okay, and hole is the bigger. Then for the interference, shaft is the greater,
bigger.
hole is the smaller. And here the tolerance zone of the shaft and hole, they are overlapped to each other. Then we can call it the transition pit. Okay. Then next is the hole basis system and shaft basis system. Okay. Hole basis system means what? Yes, faster.
Hole size constant.
Okay, hole size constant and
Shaft size
Shaft
vary.
size
shaft
varies.
size is the vary. Okay, and for the shaft basis system,
Lower deviation of hole should be
Shaft
0.
size is constant.
Just tell me the definition. Shaft basis system.
Shaft size constant.
Okay, the shaft size is the constant and hole size is the parallel. Okay. Then how many characteristics are there in the geometric tolerances?
14.
14 are there. Okay, then tell me what is the symbol for the straightness? The symbol for the straightness is yes. What is the symbol for the straightness? Just a
Straight line.
straight line. Then tell me the symbol for the position. What is the symbol for the position? Yes. What is the symbol for the position? Circle and
Circle in center lines.
like this. Then tell me symbol for the circularity. What is the symbol for the circularity?
Circle.
Yes, just we have to draw the circle. Then tell me symbol for the cylindricity. Symbol for the cylindricity is the yes circle and two lines. It is correct. It is correct or wrong?
Yes, sir, correct.
Okay, then tell me the symbol for the runout. Circular runout. Circular runout
Arrow.
symbol. Just one arrow, na? And for the total runout. Yes, total runout. For the total runout,
2 arrows.
two arrow like this. Okay. Then tell me the symbol for the line of profile. Line of profile. Symbol for the line of profile is the just like this. Okay. And for the surface, it is closed.
Closer.
Okay, like this. Then symbol for the perpendicularity. Like this. For the parallelism, yes, two inclined lines, parallel inclined lines. Then for the angularity, yes, it is like this. Okay. So concentricity, yes,
2 circles.
like this. Okay. So these are the 14 characteristics of the geometrical tolerances. Okay. So any doubt, any problem, please tell me. Understood? All?
Yes, sir.